So the big picture for this lesson is the number e. It's also called the Euler number. It's named after the French mathematician who discovered/proved the Euler number. It's also called the natural growth factor. So this is a form of the compounding interest formula, and all it is about the growth factor. What Leonhard Euler found is that if you increase n infinitely, then this value approaches a number. It's an irrational number, and it's about 2.7 roughly, and it has digits that continue forever and don't repeat. That's what irrational numbers do, so e is an irrational number. It's approximately 2.7. So the natural growth factor is important because you can use it for continuously compounding. So for example, if I have f of x equals 2 times e to the x power, I'm saying this is a continuous growth factor. So my base here is about 2.7, but what that means is if something were to grow continuously, in other words, it was compounded faster than every second, infinitesimally, then you would have an exponential growth factor base e. These base e functions work like any other exponential growth, it's just the base is about 2.7. So f of x equals 2e to the x is exponential growth. If you had g of x equals 2 times e to the negative x, that would be decay because 1 over e is about 1/3 or so, because it's 1 divided by 2.7. So the growth factor would be between 0 and 1. That would actually be a decay factor. So these graph just like regular exponential growth functions. And this is the important coordinate here, 1e, or 1, 2.7. That's where you can see the exponential growth rate. And this is f of x equals e to the x. And you can also use base e functions for modeling continuous growth, and there are examples of that in the lesson as well. Like you might have f of x equals 5 e to the x power, and then you need to find out, say, x equals 6. You would just input an f of 6 would be 5 times e to the 6, and then you'd want to do this on your calculator. All calculators have an e button or an Euler number button. So it would just be 5e to the 6th power. So that actually equals 2017, just about. So that's the Euler number, and that's the big picture for this lesson.